going again to the X-ray spectrum. Let's drag it over here. So this is what you have in your booklet on page, I think this is page 13. Okay, so here we see the X-ray spectrum. This is the continuous part that is called the soft X-ray or the Bremsstrahlung radiation. And to show why it is, or to justify why it is continuous, as I said, it is continuous because of the large distribution of the electrons acceleration that are accelerated, as we saw from the cathode to the anode. So this is why it produces a continuous spectrum, okay, due to the large distribution of the electrons acceleration, as mentioned here. Okay, yes, the spectrum consists of two components. There are continuous distribution of wavelength, which is this one, okay, with a sharp cutoff wavelength, and also a series of high intensity spikes, as we see. And these spikes, as I told you, are characteristics of the metal that is used as a target, which is in our case tungsten. Okay. Whenever a charged particle is accelerated, electromagnetic radiation is emitted. The greater the acceleration, the shorter the wavelength of the emitted radiation. Electrons are being accelerated from the cathode to the anode. The higher the kinetic energy possessed by electrons, the higher frequency of X-ray will be emitted. Sorry. So the higher speed electrons strikes metal target, larger acceleration occur, and radiation produced in the X-ray region of the electromagnetic spectrum. So as we move this way, we now understand that this corresponds to X-ray of higher energy, which are due to electrons of higher kinetic energy or higher acceleration. Okay, where are we? Since the electrons, okay, this is the important part. Since the electrons have a continuous distribution of accelerations, a continuous distribution of wavelengths of X-ray is produced, and this justifies the continuous part. Okay, now what about the spikes? I explained what causes these spikes, and we also explained why we have a cut-off wavelength here, as it corresponds to the electron that possesses the highest kinetic energy. Okay. Here it is clear that the kinetic energy has been totally transformed into what? Into X-ray energy. So kinetic energy is, which is equal to E times V. V is the anode cathode voltage, is equal to HF or HC over lambda, which is the highest X-ray with the highest energy. Now let's remove this. And get this one. Okay. Now here we have important questions. The first question is about, or the first issue is about the heating, how to solve the problem, that the fact that the target anode is going to be excessively heated. Now, how do we solve this problem? Why? Actually, because we could say that 95 to 99% of the electrons energy that are traveling from the cathode to the anode hitting the target, 99% of this energy is transferred into thermal energy, while 1% is only transferred into X-ray energy or radiant energy. Now, how to solve the problem of this heating factor? It is mentioned here that the majority of the energy of the electrons is transferred into thermal energy in the metal anode. The anode is either water cooled or is made to spin rapidly so that the target area is increased. Cooled down by water, this is clear. What do we mean by made to spin? If we represent the anode like this, the target is connected to some kind of a motor, and that the motor will continuously turn the tungsten element or the target so that the area that is subjected to electrons will be larger. Okay, and it's not going to be the same area always and always and always. No, the area will be changed every time, or the spot where electrons are hitting will be changed every time due to what? Due to the spinning, continuous spinning of the target. Okay, so that's what we mean. This is how we solve the problem of heating. In the second paragraph, there is a question here, which is about the intensity of the X-ray. The intensity of the X-ray is controlled by what? The intensity of the X-ray actually is related to the number of electrons or the rate of electrons reaching from the cathode to the anode. Actually, this number is to be controlled here by the voltage, by the heating voltage or by the filament voltage. Okay, so this is where I control the number of electrons emitted by the cathode, and therefore this will affect the intensity of the X-ray emitted. So the current of electrons that is passing from the cathode to the anode is what we call the tube current, and by controlling the tube current, as I said, by controlling the voltage at the filament, we control the tube current, and therefore we control the intensity of the X-ray. So this tube current is controlled by the heater current of the cathode, which is this one. Okay, the greater the heater current, the hotter the filament, and therefore more electrons will be released or emitted. More electrons will be captured by the metal anode or by the target. Now, the second question is about the hardness of the X-ray. On what it depends. We will see that the hardness of the X-ray is related to the energy of the X-ray, because the more energy X-ray, which is equal to HF, more X-ray energy, harder is the X-ray. This X-ray energy, as we knew before, is related to what? To the kinetic energy of the electrons. Okay, this kinetic energy of the electrons is related to what? To the anode cathode voltage. So we could say that the hardness, let's put it here, the hardness is related to the X-ray energy, which is related to the kinetic energy of the electrons, which is equal to what? To EVAC, or the anode cathode voltage, which means that I can control the hardness by controlling what? The anode cathode voltage. Okay, as we read here, so it can be seen it can be seen that longer wavelength X-ray, which is called the softer X-ray. Okay, this is what we don't need. Actually, X-ray with a longer wavelength is the X-ray that we don't need. We need X-ray with smaller wavelengths, harder or larger frequency, which is controlled, as I said, by the anode cathode voltage. So a hardness of the X-ray beam, the penetration of the X-rays is controlled by what? By the accelerating voltage. This accelerating voltage is what is here. It is the anode cathode voltage, okay, between the cathode and the anode. So more penetrating X-ray, we mean harder X-ray, more penetrating X-ray, higher photon energy, okay, this larger acceleration or accelerating potential is needed, okay, while what is, as I said, not needed is the X-ray with a lower frequency. This is what we call soft X-ray. That soft X-ray photon will be eliminated or absorbed by fitting what? An aluminum filter. Aluminum filter is fit across the window of the X-ray tube in order to absorb the X-ray or the soft X-ray photons.